In almost every household, there's a phone. The telephone was first invented by Alexander Graham Bell, and since then has been improved by others. But how does it actually work? In the simplest type of telephone, there are only three main parts. One of them is the speaker, which is a paper, plastic, or metal cone that vibrates to produce sound waves. Another is the microphone, which transforms your speech into electrical signals by being made up of a material that changes its electrical resistance as sound waves travel through it. Or, alternatively, the material can be replaced by a clever electrical circuit. Finally, a hook switch connects your phone to the phone jack when you pick it up, it being the phone, not the hook switch. This type of phone is dialed by quickly tapping the hook switch. For example, if you wanted to dial 6, you would rapidly tap the hook switch 6 times. Modern phones, however, do have a few extra parts. They're still reasonably simple, though. The duplex coil stops you from hearing your voice in the speaker as you're talking, but can be replaced by something else functionally equivalent. The touch-tone keypad is a more useful manner of dialing, and the frequency generator is the bell that rings when you're called. You're connected to the phone network via wires, at least in the case of the landline. When you speak, the electrical signals from the microphone are digitized at a refrigerator-sized box which acts as a digital concentrator, essentially converting the electrical signals from the phone wires into a string of numbers, which is then sent on to the phone company. Eventually, though, your line is connected to a line card at the switch, so that you can hear the dial tone when you pick up your phone. If you're calling someone close by, the switch will connect you directly to them, creating a loop between the phones. If you call long distance, though, your voice will be digitized and sent through fiber optic cables, or sometimes sent via satellite. That's just with landlines, though. In reality, most people use cell phones some or most of the time. A cell phone is, more or less, a glorified walkie-talkie. Your cell phone turns your voice into electrical signals, just like in the previous segment. But instead of sending these signals down a cable, they're transmitted as radio waves using an antenna. The antenna, sometimes called a transmitter or aerial, works by sending the electrical signals up through it, where the electrons wiggle back and forth, producing electromagnetic radiation as they do so in the form of radio waves. The receiver, a receiving antenna in a cell tower, collects the waves and relays them on to the other end of the conversation, using as many cell towers as is necessary to get there. The receiver in their phone then picks up the radio signals and turns them back into sound using a speaker. While calling long distance with a cell phone, the call is routed through satellites as opposed to cell towers. To keep the calls from getting muddled up together, cell phones and towers will use different frequencies or wavelengths to send the call in. Since radio waves are waves, the waves can be different sizes, much like the ones you see on the beach. Conversations sent on different frequencies won't be confused with each other, and calls on the same frequency will be bundled together so that if one person says something, everyone else on that frequency will hear it. Don't worry that your call isn't private, though, because if there are no more unused frequencies, any new caller won't be able to connect. There are about 800 possible frequencies for conversations to be held on, so to combat that limit, high-density areas will put up more cell towers, since the limit applies to 800 conversations per tower. The territory of each cell tower is a hexagonal area centered on it called a cell, and as you move from cell to cell, your call is then transferred from one tower to the next without breaking up the call. So that's how the system that links us all together works, allowing us to communicate over any distance, assuming of course that you have reception.